learning target we're going to look at is I can find the intercepts of an exponential function, and then also I can describe the end behavior of an exponential function. So let's take a look at both of them. Okay, so what do you need to know? The exponential parent function is called f of x equals b to the x, and b is called the base. So when that base value, that b, is between 0 and 1, the function shows exponential decay. Okay, so that's this part right here. And you can see on this graph that we are falling from left to right. That's what makes it have that feature of decaying. Okay, we're falling from left to right. Now, when b is greater than 1, the function is going to show exponential growth. So you can see here from left to right, we are rising. That's one feature of an exponential function. Now, the x-axis is an asymptote of the graph. Remember that that asymptote is where the graph approaches the line y equals 0, but it doesn't touch it. So every exponential function is going to have an asymptote of some sort. And if you have a parent function, so you are in this form where you just have b to the x, your asymptote is going to be the line y equals 0, or the x-axis, okay? And my graph is coming really, really close to that line, but it never intercepts the line. Now, the domain of any exponential graph is all real numbers, and that's going to be true all of the time. And then the range is all real numbers greater than 0. When we have this parent function, because my asymptote is at y equals 0. Now, we'll look at maybe some examples where this is different. We don't have a parent function and my asymptote is different. That's going to change the range. This graph passes through the points 0, 1, that's my y-intercept, and then 1, comma, b. So whatever your value, whatever your base value is, it's going to pass through that point as well. Again, this is true when we're just looking at the parent function of the exponential. The other characteristic that we can determine from our exponential functions is what we call end behavior. It's how a function behaves when the domain values, remember those are the x values, increase or decrease without bound. In other words, they continue forever. So in this example, if we look at my x values decreasing, okay, so we're looking here at the x-axis, okay, we're decreasing. If I look to see what's happening to my function as my x values are decreasing, that my function is getting closer and closer to my asymptote, which in this case, my asymptote happens to be at y equals 5. Notice I have this plus 5 here on the end. That's kind of hard to see when I highlight that. I have this plus 5 at the end. Notice how that matches the line for my asymptote. Okay, those are always going to be the same thing. If you have a plus or a minus at the end of your function, the asymptote is going to be at that spot on the y-axis. Or, yes, it's going to go through that point on the y-axis. Now, in the other direction, if I look here, as my x values increase in my function, my actual function, or the graph, is decreasing, and we say it decreases without bound because it's going on forever in that negative direction. So let's take a look at another example. So here I have f of x equals 3 times 2 to the x, and let's look at some features of this graph. So if we're talking about the domain, remember the domain are the x values. Come on. X values. So in this case, my x values are all real numbers. That's always true for the domain of an exponential function because I can plug in any value I want for x. There's no limitations. But my range is limited to my asymptote. So here my asymptote, notice it's hugging this, the x-axis here, which is my line y equals 0. So my graph is going to take on any y value above that asymptote. So y is greater than 0. We just talked about my asymptote. It's at y equals 0. The y-intercept here, you can identify that on the graph, the point where it goes through the y-axis. And in this case, it's at 0, 3. And since my since my asymptote is at y equals 0, this function is never ever going to cross that. I don't actually have an x-intercept for this exponential function. Now my end behavior, remember we look at both directions. So as x increases without bound, so as my x values are increasing, my graph, notice my graph is also increasing without bound. My function is increasing. As opposed to the other direction, if I take my function and I go in the negative x direction, my graph is getting closer and closer to that asymptote. So we say as x decreases without bound, f of x approaches the asymptote y equals 0. And typically you won't actually have to write these answers like word out in sentence form. You'll have multiple choice answers most of the time when selecting those. So you'll be able to distinguish which answer you would choose. And then lastly, it's always a good idea to analyze the graph and figure out if we have growth or decay. And since in this example, my base value, that's the value with the exponent, is 2, and 2 is greater than 1, we know that we have growth. All right, so that takes care of example 1. In example 2, now would be a great time for you to pause, try this one on your own, and then come back and check your work. So we're going to analyze the graph the same way we did the first one. Domain, remember, we can plug in any value we want for x, doesn't matter what, so my domain is all real numbers. But my range is limited by my asymptote. Where do the y values stop? Okay, like if I look at my function, here's my function. I'm getting really, really close to this line right here. So that means that all of my values of y have to be above that line. In this case, that line is y equals 2. So I can say that my range is y is greater than 2 because all of my y values for this function are above that line. So my asymptote we just said was y equals 2. My y-intercept, that's where my function crosses the y-axis, and in this case it's at 0, 3. And my y-intercept, or my x-intercept, notice it doesn't cross the x-axis at all, so there are no x-intercepts. There will sometimes be an x-intercept. I know in both examples today we didn't have a situation where it had one, but sometimes it may have an x-intercept. And then as we describe our end behavior, I'm going to go ahead and erase that highlight there so I can kind of go over that again. So if we look at how my graph is changing as my x's get larger, so as my x increases without bound, my function f of x is also increasing without bound. It's getting bigger as my x's are getting bigger. And then as my x values are decreasing, I'm getting closer and closer to that asymptote, which is at y equals 2. This is another example of growth because you can see here we are rising from left to right, but also if we look at my base, remember base, if it's greater than 1, we know that we are growing and 6 is greater than 1. So we have another example of growth. If you need more information on the topic, you can check out the Learning Target spreadsheet for additional resources, videos, and practice.